Every game you've ever played speaks a language, not English. A graphics API. When you launch a game, it doesn't talk directly to your graphics card. Instead, it sends instructions through a graphics API, telling the GPU what to render, how to render it, and how to run it efficiently. That's why the same game can run differently on Windows, Linux, Xbox, PlayStation, or even your phone. So, let's explain every major graphics API. OpenGL released in 1992, OpenGL is one of the most important graphics APIs ever created. Before it, 3D games often relied on hardware-specific code, forcing developers to write separate versions for different graphics cards. OpenGL solved that by giving developers a common language to communicate with the GPU. Throughout the 90s and early 2000s, it became the backbone of PC graphics. Games like Quake helped popularize OpenGL, while later titles like Minecraft relied on it for years. OpenGL worked on Windows, Linux, and Mac OS, making it the preferred choice for developers targeting multiple operating systems. DirectX 11. Although the DirectX family began in 1995, DirectX 11, released in 2009, defined an entire generation of PC games. If you played GTA 5 or The Witcher 3, you were almost certainly using DirectX 11. For over a decade, it was the default graphics API for Windows gaming. Its biggest additions were hardware tessellation, which added much more detail to characters and environments, and compute shaders, allowing GPUs to handle tasks beyond traditional graphics rendering. Microsoft handled much of the communication between the game and the GPU, making stable games easier to develop without low-level hardware management. OpenGL ES released in 2003. This is the mobile version of OpenGL, designed for smartphones, tablets, handheld consoles, and other low-power devices. Long before modern mobile gaming, OpenGL ES powered games like Angry Birds, Temple Run, and thousands of early Android and iPhone titles. It also became the graphics API behind Android and many generations of iOS before Apple introduced Mantle. As phones became more powerful, developers wanted lower-level GPU access for better performance. CUDA released by NVIDIA. In 2007, CUDA isn't actually a graphics API. It's a computing platform for using NVIDIA GPUs beyond gaming. Instead of rendering pixels, CUDA turns your GPU into a massive parallel processor for AI, scientific simulations, video editing, 3D rendering, and machine learning. If you've ever used Blender to render a scene with an NVIDIA GPU or trained an AI model like ChatGPT, there's a good chance CUDA was doing the heavy lifting. The catch? CUDA only works on NVIDIA graphics cards. If you're using AMD or Intel, you're out of luck. OpenCL, released in 2009, was created as an open standard for GPU computing that wasn't locked to a single company. Like CUDA, it lets GPUs handle video editing, scientific simulations, AI, image processing, and cryptocurrency mining. Its biggest advantage is portability. Developers can write one program that runs across different processors and GPUs without being tied to a single manufacturer. The downside is performance and adoption. Because CUDA is built specifically for NVIDIA hardware, it's often faster and has a much larger software ecosystem, so many AI and professional applications chose CUDA instead. WebGL, released in 2011, brought hardware-accelerated 3D graphics directly to your web browser. Before WebGL, browser games relied on plugins like Adobe Flash. WebGL changed that by letting websites access the GPU through the browser itself, no downloads required. It powers everything from browser games to interactive maps, 3D product viewers, online CAD tools, and even Google Earth Web. Its biggest strength is compatibility across major browsers, making it easy to build interactive 3D experiences that run on almost any device. Mantle, released by AMD in 2013. Mantle had a surprisingly short life, but an enormous impact by giving developers much more direct GPU access, letting games use multiple CPU cores more efficiently. One of the first major games to support Mantle was Battlefield 4, where players with compatible AMD hardware often saw noticeable performance improvements, especially on weaker CPUs. The catch was that Mantle only worked on AMD graphics cards, making it difficult for developers to justify supporting it long-term. Its biggest achievement came next. AMD donated many of Mantle's ideas to the Kronos Group, helping create Vulkan. Mantle, released by Apple in 2014, Mantle is the graphics API built exclusively for the Apple ecosystem. Instead of relying on OpenGL, Apple created Mantle to give developers direct, low-level GPU access, resulting in better performance, lower CPU overhead, and improved battery life on iPhones, iPads, and Macs. Games like Resident Evil Village and Death Stranding Director's Cut now run on Apple Silicon using Metal, showing how far gaming on Macs has come. DirectX 12, released by Microsoft in 2015, DirectX 12 was built to solve the biggest weakness of DirectX 11, CPU overhead. Instead of handling most of the work automatically, DirectX 12 gives developers much more direct control over the GPU, helping games better utilize multi-core processors and modern graphics hardware. Many modern AAA games, including Cyberpunk 2077 and Forza Horizon 5, are designed around DirectX 12, taking advantage of features like DirectX ray tracing, DXR, and mesh shaders for more realistic lighting and improved performance. Vulkan, released in 2016 by the Kronos Group, Vulkan is the biggest competitor to DirectX 12. Like Microsoft's API, Vulkan gives developers low-level GPU access, reducing CPU overhead and making better use of modern multi-core processors. The biggest difference is platform support. While DirectX 12 is limited to Windows and Xbox, Vulkan also works on Linux, Android, and devices like the Steam Deck, making it a popular choice for studios releasing games across multiple platforms. Games like Doom Eternal showcase Vulkan's exceptional optimization, while Red Dead Redemption 2 lets PC players choose between Vulkan and DirectX 12. MoltenVK, released in 2018, MoltenVK isn't a graphics API, it's a compatibility layer. It translates Vulkan commands into Metal, letting Vulkan applications run on macOS and iOS without being rewritten. That's a big deal because Apple doesn't support Vulkan natively. Projects like the Dolphin emulator and RPCS3 use MoltenVK to bring Vulkan-based rendering to Macs, saving significant development time. WebGPU, released in 2023, WebGPU is the next generation of web graphics, built to replace WebGL. Unlike WebGL, which is based on older OpenGL ES technology, WebGPU is built around modern AP is like DirectX 12, Metal, and Vulkan, giving websites better performance and access to advanced GPU features. Browsers like Google Chrome, Microsoft Edge, and Firefox have been adding support, making WebGPU one of the web's biggest graphics upgrades in years. And that's every major graphics API. Which graphics API surprised you the most? Let me know in the comments below. And if you enjoyed this video, subscribe for more tech explained simply. Thanks for watching, and I'll see you in the next one.